This is topic C on page 21, working with logical functions. Comparing and testing values, whether numbers, text, dates, or times, can be a useful tool to analyze data. The logical functions in Excel provide a method for testing various conditions to calculate a result of a value, text, or a calculation, which enable you to ask questions of your data. In this topic, you will analyze data with logical functions. One of the keys to data analysis is the ability to ask Excel questions about your data and get the answers that you need. Perhaps the most foundational set of tools to do this is the collection of logical functions available in Excel. Logical functions enable you to ask questions of your data for which Excel can return one of two values, either true or false. Logical functions also enable you to perform calculations when certain conditions are met or to perform different calculations based on a variety of criteria. By adding simple logic decision-making to your formulas and functions, you can begin to gain a whole new perspective on the information available in your raw data. Before diving into the operators and syntax associated with logical functions, you'll need to look at a new type of cell data, which is logical values. So you're already familiar with the four basic types of data that can be entered into Excel cells. We have numeric values, text and labels, formulas and functions, and dates and times. When working with logical functions and comparison operators in Excel, you will encounter a new type of data, which is logical values. Again, the only values that Excel can return when you apply a logical test to your data are either true or false. So when you're working with logical operators or logical values, you use comparison operators in the arguments of your functions. And we saw earlier that these include the equal sign, meaning equal to. You have your greater than comparison operator, your less than comparison operator, greater than or equal to, less than or equal to, and not equal to. So we'll see our first example of a logical function, which is the if function. And we'll see how to use comparison operators within the syntax of that. So on page 22 in your book, the if function tells us the syntax of this is equals and then the function name of if, and in our parentheses we have our three arguments for the if function. The first argument is the logical test, so that will be where your comparison operator lies. And when testing that logical test out, if the value that it returns is true, then the function will return the second argument in that function. So you have your value if true. If the logical test returns a value of false, then the function would return the value that shows up in the third argument where it says value if false. So the if function returns one value if the logical test you enter as an argument is true, and it returns a different value if the logical test is not true. So I have an example on the screen now. We have three different sales reps, Barbara, Thomas, and Robert, and their 4 quarter sales data all listed. Their total sales, and if you look at the top in cell B3, it has a sales goal of $6,500 and a commission rate of 9%. Now I entered an if function in cell G6. So let's take a look at that, the syntax here. So we have equals if. The first argument here is going to be, again, that logical test. So it says if F7 is greater than B3. Well, F7 is Barbara's sales total. So if that is greater than what is in cell B3, which is the sales goal, is that greater? 7131 is greater than 6,500. So the answer to that logical test is yes or true. So yes is true, false is no. So that is true. So the second argument in that if function, remember, is the value if true. So the value if true here is actually a calculation. And that's taking the value in F7 and multiplying it by the commission rate of 9%. So what that does is it makes the calculation $7,131 in cell F7, and it multiplies that by the 9% and gives you a result of $641.79. Remember that third argument, which is no commission here, is only going to be returned if that logical test in your first argument turns out to be false. So if we take a look at Thomas here, if we were to copy this if function down our whole column here for each of our sales reps, what it would say, if, we're going to move down to F8 now, if F8 is greater than B3, is $5,342 greater than $6,500? The answer to that is no, so no gives you a value of false for your logical test. So in your if function, you have your logical test, your value if true, and your argument here, the third one, is the value if false. So this is giving us a false value. So when I copy this down, it should return a result here for me of no commission. And then taking a look at the third one, so let's copy that down using our autofill. You can see I do get the text there for no commission, the value if false. Taking a look at the third one, logical test, is F9 greater than the value in B3? Is $6,259 greater than $6,500? Again, I get the answer of no there, which is false. So again, I would take a look at my third argument in my if function, and that should return a value of no commission as well, which it does. And again, I'm copying these down, so it's using relative referencing to look at F9, F8, and F9 instead of F7. So it's moving down one cell. But we used our absolute references for cell B3 to make sure it stays on that sales goal cell. And same for the calculation in the value if true, telling you to stay on the commission rate of B4 if needed. Okay, our next logical function that we'll take a look at on page 25 is the AND function. And the syntax for the AND function is equals and then you will have either one logical test or you can have multiple logical tests here. So the AND function returns the logical value true when all arguments entered in the function are true, and returns the logical value of false if any one or more of the arguments are not true. So here on my AND worksheet, I have the values A1, we have the value of 10, A2, we have 15, and A3, we have 20. So using the syntax here for my AND function, we'll have a few examples. Equals and let's say I have A2 greater than A1. I'm going to put a comma here to move to my next argument, and we'll do A1 equal to A3. So before I hit enter here, we'll analyze this for a minute. So remember, the book tells us the AND function returns the logical value of true when all arguments entered in the function are true, and returns the logical value of false if any one or more of the arguments are not true. So if we take a look at the first argument here, we ask, is A2 greater than A1? Is 15 greater than 10? So the answer to that is yes, so we get a true value here. Now, AND functions need to return all values in their argument of true to return a true value. So we take a look at the second argument. Is A1 equal to A3? Is 10 equal to 20? The answer there is false. Now, only one argument, you could have, numerous arguments in an AND function. If any one argument is false, that will have the whole entire function return a value of false. So since my second argument is false, when I hit enter here, you can see I do get the value of false for this AND function. So let's take a look at another example. We'll do equals AND function. First argument, A1 less than A2, and our second argument will do A2 less than A3. So taking a look at this, first argument, is A1 less than A2? Is 10 less than 15? Answer to that is yes, so that is a true. Second argument, is A2 less than A3? Is 15 less than 20? That's yes as well, so that is true. So both arguments here have a value of true, so this whole entire function will return a value of true. Another one, equals and first argument, A1 less than A2. Second argument, we'll do A1 greater than A3. So is A1 less than A2? Is 10 less than 15? Answer to that is yes, so that is true. Is A1 greater than A3? Is 10 greater than 20? Answer to that is no, so the second argument returns a false. Again, only one false is needed for an AND function to return whole entire value of false for the function. And let's do one more. Equals and first argument, A1 not equal to A2. And we'll do 1 plus 1 equals 2. So I don't even have a cell reference. I don't even have comparison operators of cell references used here. I actually have a calculation which you can test for as well. So same idea. Look at the first argument. A1, remember this comparison operators, these two when they're facing each other means not equal to. So is A1 not equal to A2? Is 10 not equal to 15? Correct. They're not equal to each other, so that is true. And then the second argument, does 1 plus 1 equal 2? That is yes, so that returns a true value as well. So both arguments return true. So the whole entire function returns true as well. Okay, so just remember for AND function, all arguments have to return the value of true in order for the whole entire function to return true. If any one single argument returns false, that makes the whole entire function false. Now the OR function is similar, except only one argument within an OR function needs to be true in order for the whole entire function to be true. So remember with AND, all of them had to be true. For OR, only at least one of them needs to be true in order for the whole entire function is true. The only way an OR function will return a value of false is if every single argument in that function is false as well. So the syntax for here, we have equals OR, and then again, same as the AND function, you just list your arguments here. So we'll do equals OR A1 less than A2, And our second argument, we'll do A2 greater than A3. And our ending parentheses. So, is A1 less than A2? Is 10 less than 15? That's a true. Now remember, for OR function, you only need at least one value of your arguments to be true in order for the whole entire function to be true. So I don't even technically need to look at the second argument in order to determine this function. I have one true already, so this is automatically going to be true. But just to take a look at the second one, is A2 greater than A3? Is 15 greater than 20? That's a no, so that's a false. But again, my first argument is already true, so I only need one of those to be true for my OR function. So my second example, we have equals or A1 greater than A2, A2 greater than A3. So is A1 greater than A2? Is 10 greater than 15? Answer to that is no, so that is a false. Is A2 greater than A3? Is 15 greater than 20? Answer to that is no, so you return a false here. So we have two false arguments. So two false arguments will return a value of false. And then our last example for our OR function, we'll have equal or our first argument, A1 equal to A2. And our second argument, we'll have another calculation, 1 plus 1 equals 2. So the first argument, is A1 equal to A2? Does 10 equal 15? Of course, that's no, so that returns a false. Second argument, does 1 plus 1 equal 2? Yes, it does, so that's a true. I have at least one true in my OR arguments for my OR function, so that will return a value of true. So again, to repeat, AND functions need all of the arguments true in order to return a value of true. One false will make the whole entire function false. Or, in order to be true, only at least one argument needs to be true. If all arguments are false, that will return a value of false. Okay, and then our last function that we'll take a look at in this section is the NOT function. This is on page 26. So the syntax for the NOT function is equals, not, and your logical test. So this is a logical function used to reverse the value determined by a logical comparison. If the comparison within the NOT function is determined to be true, the NOT function returns a value of false. If the comparison is determined to be false, then the function returns a value of true. And this is usually just to return, it's usually used to reverse the behavior of another function. So for our examples here, we have our same values, 10, 15, and 20. Again, the syntax is equals, not. And let's say we have A1 greater than 0. So is A1 greater than 0? Is 10 greater than 0? Yes, it is, so that's true. But the not function will take the opposite of that. So not true is going to return a value of false. So whatever is inside the argument, whatever value that returns, you're going to take the opposite of that. Our second example, we have equals not, and we have an AND function nested inside of that. So let's take a look at that. You can have functions inside of functions. We will keep them relatively simple throughout this course, though. So we have A1 less than A2. And A2 less than A3. So with a nested function, you always start from the inside and work your way out. So we would actually take a look at the value that the AND function returns first. So we have AND A1 less than A2. So is 10 less than 15? That returns a value of true, because that's a yes, so that's true. Is A2 less than A3? Is 15 less than 20? Yes, so that is true as well. So we have two true arguments within an AND function. Remember, all of the arguments have to return true in order for the function to return true. So for an AND function, we have two trues here. So that AND function will return a value of true. So that answer of true then becomes the argument for your NOT function. So not true is going to return a value of false here. That just came up because I forgot to put the last ending parentheses there, but it fixed it for me. So always start from the inside function and work your way out. So the AND function returns a value of true. That becomes the argument of the NOT function. Not true equals false. So let's take a look at one more of those. Equals not. We'll do another nested function. First argument here we'll have, let's do an OR. We'll do OR A1 greater than A2. And we'll do A2 greater than A3. So again, work your way from the inside out. Now this is an OR function. Remember, only one value of the arguments needs to be true in order for the whole function to be true. So we have, is A1 greater than A2? Is 10 greater than 15? That is a no, so that is false. Is A2 greater than A3? Is 15 greater than 20? That's a no as well, so that is false. Two false arguments in an OR function will return false. So that false becomes the argument for your NOT function. So equals not false. Not false is true. Again, fix my ending parentheses there. Okay, so again, work your way from the inside out for a nested function. And we'll see another example of that in the next section. All right. Your next video will be activity 1-4 on page 27.